So in this video, we are going to start with troubleshooting your OSPF configurations. Like take an example, in your production network, you have some multiple routers. Let's say I got some 4 routers running in my production network, and the router 1 LAN is not able to access the router 4 LAN resources. So in all the routers we are running OSPF as our common protocol. It can be a single area or it can be multiple area. It doesn't make difference. So the troubleshooting remains the same. So whenever we do troubleshooting, as I said in our basic routing video, identifying the problem on router 1, router 2 or router 3, router 4, that is a basic important thing. And make sure that your LAN users must be able to access the gateway of the router, and the router 1 must have a route in the routing table. Okay, so if router 2 is able to access the router 4 LAN, which means the problem is between router 1 and router 2. So make sure that you have a connectivity between these two routers and verify your neighborship. So when we troubleshoot your OSPF and EIGRP, the basic thing we need to verify is our neighborship. So for the first thing, make sure that your neighborship is up between all the routers. So I'm going to take some routers here, assuming that I got some 4 routers here, and the LAN users of the router 1 is not able to access the LAN users of router 4. So now from here, router 1, router 2, router 3 and router 4, I'm not able to access the router 4 resources. So figuring out where the problem is. The problem might be between router 1 and router 2, router 2 and router 3, or router 3 and router 4. So make sure that from router 2 you should be able to access the router 4 LAN. If you're able to do that, then the problem might be between 1 and 2. It can be the connectivity or it can be the routing configurations. So if you realize the problem is between router 1 and router 2, just make sure that the neighborship is established between them or not. So the first thing I'll do is I'll make sure that the router 1 and router 2 are forming the neighborship or not. In case if they are not forming the neighborship, there are multiple reasons for that. And troubleshooting OSPF or EIGRP, the neighborship is a basic thing we need to verify. So now there are some multiple things we need to check. If the neighborship is not forming, make sure that the interface connecting between 1 and 2, you should try to ping to this interface. If you're able to ping to the opposite interface, which means the connectivity between them is perfect. So which means if the connectivity is perfect, in that case we need to verify the OSPF configurations. And in that, the first thing I'll do is I'll verify the neighborship. So now if the neighborship is not coming, so most likely there are many reasons for that. So we are going to figure out what are the possible reasons which might affect your neighborship. In that, the first thing, advertisements. So if the router 1 connecting to router 2, they are not forming the neighborship, and when they are not forming the neighborship, the first thing we need to keep in mind, did you advertise both the interfaces or not? If you advertise one interface and if the other interface is not advertised, in that case they will not form the neighborship. And once you confirm that both the interfaces are advertised, so we can verify with this command show IP OSPF interface brief, or we can use show run section OSPF, which will give you which interface is advertised in which area. I'll shortly come to the lab where I have pre-configured errors in my routers. Through that we are going to do troubleshooting anyway. And once you confirm both the interfaces are advertised, make sure that these two interfaces are advertised in a common area. This is very important. If you advertise one side of the interface in area 0, and if the other interface is in different area like area 10 or area 1, anything, mismatch of area will affect your neighborship. So make sure that the interfaces facing each other must be on the same area. That is a mandatory rule which the routers has to be designed in, and make sure that opposite interfaces must be on the same area. So once we confirm that these two things are correct, then most likely the reason might be a hello mismatch. So one side of the router, by default OSPF send hello messages for every 10 seconds, and the dead time is 40 seconds on most of the point-to-point and broadcast interfaces. So if you misconfigure, like let's say on the opposite side we decided to change the hello parameters to 5 for faster convergence, and by default it will take into 4, automatically it will take 20 seconds as a dead time. Mismatch of hello parameters, maybe your company decides to change the hello parameters to 5 seconds, but you forgot on some of the interfaces. It will also affect your neighborship. So make sure that you don't change the hello parameters, and in case if you change, both the interfaces facing each other must have a common hello parameters. and you can always verify with this command, show run interface command. And there is one more command called show IP OSPF interface and the name of the interface, S1 by 0 or S0 by 0, whatever the interface connecting between the routers. So these two commands we can use for verification. And the next likely reason is authentication. Authentication we do in CCNP, where we'll see how to configure authentication in case if you are using authentication and if there is a misconfiguration of passwords. So one side you're using a Cisco 123 as a password, and the other side you're using Cisco as a password. Mismatch of authentication also will affect your neighborship, and in this case I'm not using any authentication in my labs. And if you're watching these videos in your CCNA class, probably you will see more in detail about how to configure authentication in your CCNP videos. And the next reason might be MTU mismatch. Especially when you're using MTU mismatch, by default the MTU size will be 1500 bytes. Okay, and in case due to some reasons I have changed the MTU size, or if you're connecting some switches, layer 3 switches, the MTU might be different in the router and the switch. In that case also it will affect your neighborship. Like let's say I'm using 1300 bytes of MTU size, maybe I changed to 1300 bytes, and here I'm using 1500 bytes. So I did some troubleshooting in my lab here. So we'll see these things, how to verify these things. And when you see this, your neighborship will stop at Xstart stage. When you use show IP OSPF neighbor, whenever you see Xstart stage, you have to understand you have some MTU mismatch issues. So that might be one of the reason for your neighborship will be stuck in Xstart stage, or it might be network type. So by default, in case if I'm connecting my serial links, the default network type will be point to point. So by default network type must be same on both the sides. But maybe if I change this point to point interface to some other network type, maybe non-broadcast, or which is a frame relay network, or if I change to other network type, in that case also your neighborship will not happen. So you need to make sure that network type is not mismatched, and that you can verify on show IP OSPF interface command, or you can use show run interface commands. So even you can use show IP OSPF interface and the name of the interface. And then finally stub flag. There is one more thing called stub flag. Stubs you'll see in CCNP, where one router is configured as a stub and the other router is not configured as a stub. In that case also the neighborship will not occur. Stubs is something very advanced concept you will see in CCNP. And after that, finally there might be some ACL implemented on the interface which may deny your traffic. And finally, if you are not sure where the problem is, or if you're not able to figure out, then still you can use a command called debug IP OSPF events command, which will give some debug outputs, the backend process outputs, which will really help you to understand what might be the problem. But if you are really good with OSPF, then you will never need this command. Personally, I don't use this command most of the time, because I know most of the possible reasons, so probably I can easily troubleshoot OSPF, but I want you to be at that point. So these are some of the things which might affect your neighborship. So if the neighborship comes, then definitely the routes will come. So let's say the neighborship is up between the routers, still this route is not coming, means definitely either you are not advertising this interface, or might be there is some route filtering methods applied which is denying the route. So route filtering, again, it's a advanced topic which we do in CCNP, route filtering separately. So let us verify this practically. So what I'm going to do is I'm going to implement my lab here, where I got a pre-configured topology with 4 routers, and I already inserted some of the problems in this topology, which means now you'll find some problems here already pre-configured. Whatever the problems we discussed, I have already made some errors into it, and now my intention is to make sure that my router 1 LAN interface, which is 10.1.1.1, is not able to access the LAN interface of 4111 of router 4, and they are connected like this. Like this is my area 10, and this is my area 0, and then this is my area 20. I got multiple areas. Now I'm going to troubleshoot this. What are the possible reasons? So when you do troubleshooting, the first thing, assuming that all my connectivity is perfect, I'm going to do it on my router. So I got the console screen of my router here. First I'll start with the neighborship. So I'm going to verify router 1 must establish the neighborship with router 2 here. As per my diagram here, router 1 should have one neighbor here. So if there is no neighbor, in that case there is some problem. So you can see there is no neighborship. The first thing I always suggest you to start with basic advertisements. To verify the advertisements, I generally use this command, show IP OSPF interface brief. Really very good command, because it is going to list you all the interfaces you are using, what is the process ID you are using, and also it will also show you which area you are going to advertise that interface, and also it will show you some cost information and type of the link, something like that. So it really gives you a lot of information in a single command. Or if you are not much used to this command, you can always use show run pipe symbol and section OSPF command, which is going to show you the complete OSPF configurations. You can see there is a timer mismatch. Anyway, we'll come to that. Let us first check, make sure that we advertise the interface connecting between 1 and 2. You can see this interface is advertised, but as per my diagram, this interface and these two interfaces must be in area 10, but here it is in area 0. So which means there is a misconfiguration of area. So troubleshooting we need to do, we need to make sure that we change the interface connecting between 1 and 2 must be in which area? It must be in area 10. Okay, so as per our diagram, as per documentation also, now we can see the neighborship changes has been done. If there is no problem, I should see the neighborship. So I'll verify show IP OSPF interface brief, and you can see S1 by 0 interface is in area 10. If I check the router 2, on the router 2 also S1 by 0 interface must be in area 10. The interface connecting between S1 by 0, this is in area 10. So mostly both the interfaces are advertised. These two interfaces are advertised, and also they are in the same area. So still there is a problem, which means we need to check the other configurations. So we verified these two things. Okay, so I'm going to verify my hello and intervals. Probably hello and enter. Whenever you use this command, the first thing I'll use advertisements and area, and the next thing, if you realize that everything is okay, then simply you have to jump to the interface configurations, because whatever the things I listed here, if you try to see here, most of the things like hello parameters, authentication, MTU, network mismatch, all these things are interface specific commands, which means in case if you have any configurations relating to authentication or hello intervals or MTU or network type, they will be under the interface. So I suggest you to just simply jump to my interface, show run interface command, to verify is there any extra command affecting my neighborship. So directly jump to that command. If you try to see here, this is a normal command. I'm not using IPv6 as of now. You can see this is a command. So which means on the router 1, we have changed the parameter to hello parameter to 5 here, which means it should be 5 on the other side also. But let us verify on the router 2. So show run interface is 1 by 0. There is no command here relating to hello parameters. We'll see come to this command again, because I have a very small diagram, so I try to put all the errors in on any two neighbors, between every two neighbors, so don't worry about that. Either I can use this command also, show IP OSPF interface S1 by 0. So this command will show you what is the default hello parameters. Here you can see 30 and 5. You can see this is 5 and this is 30. Why it is 30? Because by default, if you change the network type to non-broadcast, it will automatically take 30. So if you check my interface configurations again, I change the network to non-broadcast. Non-broadcast is something which doesn't work in this case. I'm going to remove this. Okay, so now if I verify again, show IP OSPF interface S1 by 0, which is connecting router 1 and router 2, now you can see the hello parameters 10 and 40. So in our scenario here, we change to 5, and here it is using default mismatch of hello parameters. So now there are two possible solutions. Either you change this side to 5 or remove this so that it becomes 10. So either of the solution works for you, but it's up to the requirement of your organization. You need to check Maybe my organization want a faster conversion, so I will use 5 hello seconds on both the sides. So it's up to you. So once I match both the sides, automatically now I should see the neighborship comes up now. Show IP OSPF neighbor. Now the router 2 is forming the neighborship with the router 1 on 1.1.1.1. Okay, so let me just quickly summarize what we did. In this router 1 and router 2, they were not forming the neighborship. In that, the first reason was this interface was advertised in area 0 and this interface was advertised in area 10, so I changed this to area 10. Still I was not forming the neighborship because there was also hello mismatch on. There was one more reason, network type mismatch. This side it was configured as MBMA and this side was by default running point to point. Mismatch of network type also will affect your neighborship. So what I did, I removed this command. When I removed this, automatically it becomes point to point. So network type matches on both the sides. Still it was not forming the neighborship because there was a 5 hello seconds, means hello has been changed to 5 here and this was using default 10. So what I did, I removed this and made it to 5. So in the same 2 routers, I inserted 3 issues just for troubleshooting and verification. So you'll get a good idea on how to verify and way to verify these configurations. That's the reason I have inserted some multiple issues on router 1 and router 2. So now, as per our scenario, router 1 should form router 2 forming a neighborship with router 1 and router 2 forming the neighborship with router 3 also. So let us verify on my router 2. I'm getting into my router 2. I should see 2 neighbors. You can see I'm able to see the neighborship with 2.2.2.2, which is my router 3, and 1.1.1.1, which is my router 1. The neighborship is okay here, so it's working fine for me. So now the next thing we need to do is we need to make sure that router 3 also forming the neighborship. So I'm going to router 3 now. On the router 3, I'm going to verify my neighborship. On the router 3, I'm able to see the neighborship between 2 and 3. You can see, and between 3 and 4, I don't see the neighborship, but the neighborship stops in exchange or start stage. So there is some problem here. So the most likely the reason is when you see the neighborship stuck in exchange or start stage. If I check on the router 4, here also I can see the neighbor stuck in start stage because of MTU mismatch. And whenever you see this type of message, you directly need to jump to the interface. You can see on the serial interface here, I have changed the MTU to 1300, whereas on my interface, which is on the router 3 interface, this interface, it is not configured. So which means by default it is using 1500. So if you want to verify this MTU, you can verify in show interface command, where you can see the default MTU size will be 1500 bytes. So now there are 2 possible solutions. Either you change this side to 1300 or remove this command. So I'm going to remove that command from my interface. So no IP MTU 1300. But sometimes when you're using a router to switch connections, changing the MTU may not be a possible solution. So in that case, I can just use this command, IP OSPF MTU ignore. This command is very useful in case if you want to form the neighborship even though there is a mismatch of MTU, then you need to configure it as IP OSPF MTU ignore command. Even though mismatch of MTU, still form the neighborship. Now I can see the neighborship is up. Now finally I can see all the neighborships are up. Finally, if I verify my routing table, I can see the routes of router 4 coming into my routing table, that is 4111, and I should be able to ping to 4111. You can see if I try to trace 4111 with my router 1 from my router 1, I can see the communication is happening. So these are some of the basic things we need to check when we do always troubleshooting. So still, if you see the communication is not happening, then after forming all the neighborship, most likely the reason is the interface may not be advertised. And if you see the routes in the routing table but there is no communication, I'm able to see the routes but still I'm not able to see the communication, means in between any of the routers has been configured with some ACLs which is denying the traffic or denying the communication between router 1 LAN and router 3 LAN. So make sure that it should be permit if as per the rules. So if you want to deny it, then it's okay, but still if you don't want to deny, still it is denying, means there is a misconfiguration of your ACLs. You need to check your ACL configurations and fix it and make sure that it works fine. So thanks for watching.